My name is Vinay Banai. I work for PayPal, which is owned by eBay Inc. So we've been deploying cloud for a long time, and more recently, the last year and a half, we've been trying to also virtualize our network. So what that means, SDN is a heavily overloaded term. It means different things to different people. So we have been using SDN for a lot of flow management. But for us, SDN is not necessarily the end, per se. It's like a means to an end. Our end goal being software-defined data centers, because there's a compute element, there's a storage element, and network happens to one, which stitches together. So I'm part of the cloud engineering group, and I've been invited on a couple of occasions to participated in NFV events in the past, and I did present some of my slides. And I did have some slides today, but I was told no slides, so if someone wants, we can talk about it later.
Okay, I have one here that's working, I think. So I'm Andy Randall, run the networking business unit at Metaswitch. Metaswitch, some of you may know from businesses that we have in the carrier VoIP and virtualization of VoIP networks, where, as Edward says, SBC, IMS, and those kind of areas are what we specialize in. In the networking business unit, we've typically worked directly with equipment manufacturers, so everyone from the likes of Cisco and Alcatel-Lucent through Dell Force 10, Brocade, those kind of guys. So very much a standard embedded technology for IP routing, MPLS, and traditional networking protocols, if you like. So our approach to SDN and specifically to the topic of white boxes that we're talking about today has been really to look at how networks will evolve, and to look at those long-term trends, and specifically what that means for the networking software piece. And I think, particularly when you talk about white boxes, there's two very distinct but parallel and important trends that are happening. One, in terms of what's the evolution of hardware, and what happens to price points, what happens to what happens to the price curves over time of various different hardware architectures. And then, secondly, what's the software architecture that runs on top of that hardware evolution? And they're linked, but we kind of talk about SDN and NFV and kind of muddle these up, I think, sometimes. And we're very much focused on, I think the hardware trajectory is pretty clear where that's going, and it's important that the software trajectory is kind of in lockstep with that. So we're focused on how do we take those technologies as that hardware architecture and the software architecture evolves, and bring them into a new kind of SDN architecture.
So I'm Reza Malikzadeh, and I'm responsible for the business function as Cumulus Networks. So as Ed said, we're a startup company, and we provide a Linux operating system for the white box industry. So we believe that today the quality of hardware from the white box is very, very good. The availability of the merchant silicon from Broadcom in particular is very good, and most OEMs and incumbents actually are now using that merchant silicon themselves. And so we aim to provide the operating system for that white box, and we believe that Linux is actually the best construct to do that, because it brings a large number of operational benefits, and that's what we're focused on bringing to the market.
Quality of service is very important, and you get different types of traffic flows. You have storage coming over. You also have customer production traffic coming over. That's more external. And are you able to, with both of those traffics hitting the server, can you separate out those two types of traffic flows? And can you perform QoS equally over those two traffic flows? Or how do you do that?
Okay, so I want to first differentiate the questions, because I think there's this notion of support and quality, and then there's quality of service at the software layer. Those things are completely different for me. I think on the first side, and I'd like to address it kind of proactively here, what you will find is that the devices that are being manufactured today, or sold, I should say, by the OEM incumbents, the Junipers and Dells and others, are not manufactured by them. And if you go to one of these original device manufacturers, be it Acton, Delta, Quanta, and you'll find a handful of those, you take one of those boxes, and then you go and take a box from a Juniper or Dell. If I remove the logo, you can't tell the difference, because fundamentally it's the same box. And so if you trust the hardware from a Dell or a Juniper or another OEM, it's the same boxes from the ODM, just with a different logo on it. So in our customer base, once people view that, understand that, they don't have a quality perception issue anymore with the ODM boxes. And you'll find that the white boxes have the same quality from a hardware perspective. And then, by the way, it's the exact same Broadcom chip. So if you start running performance tests, because all the networking functions are going to be handled by that SoC, you will find that it's actually the same performance. So then it gets to, if I have an issue with a white box running Cumulus Linux on, who do I call? Do I call the ODM or do I call Cumulus Linux? Well, we as a business function provide that first line of support, meaning if our customers have a problem, if the hardware is on our hardware compatibility list, we'll take that call. But if I get to the second part of your question, when you're talking about quality of service, those are really software functions on whether the software stack that you're running is going to handle this or that type of feature. So the feature set that we support is not today obviously as broad and wide as a Cisco would support, because we're still a startup company and we're growing that. But we've chosen to be very much focused on the modern data center and how the large-scale, web-scale properties like what a PayPal or an eBay would do would be the type of use cases that we would be supporting first. So some software stacks or some ways you might architect your network will allow for that separation. Some might not. We don't claim that we have the full 10,000 spreadsheet line of features that a Cisco has, but we're growing slowly, and we think that for that modern data center construct, to a great extent we do. And if you start using an SDN or an overlay solution, actually what we do doesn't really matter anymore. What you want is for us to provide a very high capacity fabric at a very affordable cost, and you will handle all of that in your SDN layer. And at that point, we're not in the middle anymore. So you can run VMware's NSX, you could run Nuage, PlumGrid, whichever overlay you want on top of a white box running Cumulus Linux.
And if I can add to that, so Metaswitch's perspective on that is that we're coming in with essentially, because we have provided historically the carrier grade routing protocol stacks, that you couple the kind of capabilities that we bring with the rock solid hardware, and then an infrastructure such as Cumulus Linux, which provides the programmability and the automation and reduction in OpEx. Then you have the best of both worlds best of all of those worlds, right? Across the board, the capabilities and the features that you would have with a carrier grade routing stack coupled with these white box solutions.
Mark Cohn, I know you have a good question.
Thank you. I certainly agree, Reza, about your perception about the hardware platform in general. And again, for the data center where you have a pretty heterogeneous environment, or at least relatively speaking, where the hardware is really based around the silicon. And even in the cases of whether there's an ASIC, maybe it's functionally equivalent, because Broadcom has really come a long way, no question about that. The question I have is that in the carrier environment, there are other opportunities for hardware to play a bigger role at the switch that are not as genericized and implemented in Broadcom chips necessarily. And I'm just sort of curious, again, because the theme of the session, or at least in my mind, given the context, is about how does this play out in the carrier network versus the data center. I'm just sort of curious on your thoughts of what's the applicability in carrier segments where hardware does play a bigger role. And some examples might be high availability comes to mind off the top of my head, maybe monitoring, and these are very high-speed networks, especially as you get closer to the core. I'm with Ciena Corporation. Of course, optics comes, photonics and optics comes into play, and not at all generic and commoditized and so forth.
Sure. Good luck. Actually, I have a very pragmatic question answer, which is, I don't think it applies to most places today. I think I view this session and the conversation around, will it change in the future, and is that the direction? I fundamentally believe that we can't really afford to pay the massive margins that a Cisco asks, and that's just not scalable anymore. And the same way server commoditization didn't happen overnight, and it didn't do everything, and virtualization didn't replace every use case. But I think this is the direction. So in all those areas where today hardware is super important, I have no argument. I agree. You have to go get still specialized hardware. But I think that what you'll see is that if as our capabilities grow, as the hardware capabilities grow, and as you have more and more functions like what Andy here was describing and having very focused stacks that will run on that, you will start getting more and more benefits because the price will come down, because the capacity you'll be able to get for that budget will go up, and the pace of innovation will grow. And our view is that innovation hasn't happened in the networking space the same way it has happened in the server space. Just look over the past 10, 15 years, how much more server compute capacity do you get for $1 versus how much more network capacity do you get for $1? And it's not there yet. So it will get there. That's our view. It's not going to happen overnight, so I'm not at all trying to say that it does. But I think that if you think about it and in the places where you think, yes, the Broadcom-based hardware is going to do what I need it to do because I'm going to use an overlay or I'm going to use something else on top of it, then start implementing it and the economic benefit will start growing.
Yeah, I would like that. So Mark, let me give you a data center perspective. So today we have in our data centers, like a rack. Each rack has got like close to 100 servers, physical servers, right? And these are servers which are like in the high end, 256 gigs of RAM, 32 cores, So I have 100 of those sitting in each rack. Guess what? Each of them run a virtual switch. And this virtual switch, we've done performance where we feel that VM to VM across virtual switch, bidirectional with 10 gig, you don't see any performance drop. There is an increased latency when you use overlays, but not very, very high. So if I do the math, for every top of the rack switch, I have like 50, or if I'm using redundant top of the rack switch, like 25 virtual switches per rack. That's a big number. And these are software switches. That means they're very intelligent. I can do a lot of cool things. I can do distributed firewalls. I can do distributed load balancing. I can do distributed switches. So when I have my intelligence getting sucked into virtual switches, what I would like to have my top of the rack and distributed routers do is provide me basic layer 3 transport, as Raza pointed out. And this should have, so just from the top of my head, it should have OSPF, BGP, ECMP, VLAN done. So I mean, there may be, I might be missing some more things, but if I were to go in the market and buy from a legacy vendor, I have a ton of features that I don't want to use. And it makes it more complex. The software becomes a little unstable. So in my viewpoint, for Whitebox would be an ideal situation where you have top of the rack and perhaps the gateway nodes and maybe the routing level. And this might makes very good sense for overlay networks. So that's my data center perspective from that.
I agree. What Reza says, Whitebox is not applicable to every application in networking right now. But I do think there are carrier network applications. It's not purely data center. And I think a couple of reasons for that. One, with the general trend of NFV, we see a lot of carriers building out what look a lot more like data centers. If we look at how carriers are building an IMS infrastructure today, it looks just like a data center that Vinay might build, right? So all those applications are very important. We also see some carrier applications, some very real ones where carriers are looking at the hardware, understanding the restrictions and trying to find places in the network where they'll fit. So, for example, we have one proof of concept that we're working on that's essentially using Whiteboxes as an aggregation device and offloading a lot of the L3 intelligence off of the edge router. Another application further into the core, we're having one carrier looking at the MPLS capabilities of Whitebox switches with OpenFlow on them and with us as a controller doing all of the MPLS signaling functionality and having it be a label switch router. Not all the intelligence and traffic shaping and all of the features that they need in an edge router they keep in the traditional devices, but just for pure connectivity, and it works, and it's a very good match. And similarly, another example in a data center environment, we have one customer that we're working with that's doing, that wants to have the border router into their data centers be a Whitebox. Now, traditionally, they couldn't do that because the table size that they'd have to have in that hardware would be much greater than you could get in the Broadcom hardware today. What they're doing is they're putting that intelligence into the hosts, into the servers, into the virtual switches, pull it further into the network, and then use label switching through that device, and just have a label per carrier that they're interconnecting with, and then you go from needing hundreds of thousands of routes down to a few hundred or maybe 1,000, which is absolutely within the capability of the hardware. So in some cases it's applicable. In other cases, we're seeing customers redesign how the networks are architected to work around today's limitations.
All right, I have actually a couple of questions. The first question is that if I'm buying a white box from vendor X and the software from vendor Y, who's doing the integration? Today, we know if you buy your mobile device, it comes already preloaded with the operating system. Or if you buy your laptop, it's the same thing. It comes with Windows. And typically that relationship is 1-to-1, right? And the second question is that if Cisco decides, or Broadcom for that matter, decides to sell white boxes, can they kill the rest in the market? And could we see Google one day or Facebook essentially selling servers and switches since they're building their own? Thanks.
So the first part of your question is about basically who's doing the integration. And so we've seen, at least in our experience, two models. Either it's a reseller or a system integrator who does it. So our medium to larger customers have a list of resellers that they want to work with, and those resellers typically will carry the white box and carry our software as well. They'll do the installation and sell it to the customer. For our much larger customers, what we found is when they're world-class size data center, they will go and buy the ODM hardware directly from the ODM, and they typically want to have at least two vendors, so they have a multi-vendor strategy, and then they come and buy the software from us directly in an enterprise license agreement type environment. So you have the two options are pretty much available to you as to what you would want to do. The customer preference in terms of the procurement doesn't really impact the support, because even if a customer has bought the hardware directly and the software directly, at least in our business model, we will still provide that first line of support to them. Right. Then the second part of the question, which was? Sorry.
Would Facebook or Google end up selling
yeah.
switches?
So it's pretty well known that Google actually manufactures their own switches and servers, and or at least has a contract manufacturer do it for them and does their own software for it, and they're very, they keep it to themselves. Facebook has taken a slightly different approach. They have an initiative called the Open Compute Project, and as part of that, they were initially focused on the server designs, and more recently, they just made an announcement that they're opening or having a networking component as part of the OCP. So the announcement was early November, where Intel, Mellanox, and Broadcom each contributed a switch design to the OCP. So you can go to the Open Compute Project, and Intel has a x86-based design for a switch, and Mellanox has their own, and Broadcom has their own. And a variety of the ODMs are going to be carrying those OCP-designed switches. And then there's another piece, which is how do you get the software on these switches? Because traditionally, networking devices are kind of locked. You can't really easily install an operating system on them. And so a project that we contributed to the OCP is something called ONI. It's the Open Network Installed Environment. And it's a very, very small kind of micro Linux operating system which will ship on those switches. And its only function is to wake up the switch and look for where to install the operating system from. So although it's not technically accurate, it's kind of the same analogy as a BIOS that you would have on a piece of x86 server or PC. And so if you add the two, then you can say, hey, I'm going to buy this switch from this vendor. I'll put Cumulus Linux using ONI. Or you're unhappy with us. You want to go and put Big Switch Lite on it. You can actually install Switch Lite on the same switch. Or if you're unhappy with the hardware vendor, you can swap hardware vendors, and your investment in the software will remain the same. So all these things that the server manufacturers, the server customers have been used to and they take for granted, now we believe that actually Facebook's OCP initiative is going to help bring further into the networking world. I just don't see Facebook selling hardware, but I might be wrong, though.
I was just going to say, I've been around the industry for a little while and saw the evolution from mainframes to PCs, and I think there's, you can translate that question into what happened, 30 years ago in the mainframe world, and the proposition at that time from IBM was, as they brought in the PS2 line and brought out OS2, that they would own that entire ecosystem, and there were purchasers at the time who wanted to get everything from the one trusted vendor, and that was the strategy. But in the end, the open architecture, the enhanced industry standard architecture, and kind of how that evolved with guys like Compaq and Dell building low cost hardware, and then Microsoft building Windows and Linux. You wouldn't worry today as an enterprise buying servers, who's going to do that integration. It's how an open ecosystem will survive, and it has to work in order for those vendors to make a success of it.
Hi, two questions, a little maybe challenging statement from Vina and Reza. There, I'll start maybe from Vina. You said that you don't see much performance degradation when you run your network with the vSwitches. One of things that probably we forget that vSwitches still take cores. Normal open vSwitch implementation runs on 2 cores, which in your 32-core system takes about 6% of the resources. It has nothing to do. I'm not saying that, it's not worth it, extra functionality probably worth it, but it's still, you pay that amount. The principle is simple. If you need to run extra instructions, you need to run extra resources. So that's the first part of it. Of kind of statement. The second one, when I go to Reza, Reza mentioned that all hardware is equal if it's built on the same chip. I would challenge that. As a system integrator dealing with the companies like Broadcom and Marvell and whoever it is there, they're not equal. And by the way, Broadcom that is used in Cisco boxes is different from Broadcom that is used in other boxes, even if it looks the same or very similar. Because inside it could be totally different. They actually OEM different devices. They have extra functionalities, they have extra things, they have extra resources, they have different performance. So I know it's not everything equal. And even if it is the same chip, many times the system that defines your functionality and your performance, not only the chip itself. You can build Broadcom with this amount of memory or with that amount of memory, with this TCAM, without TCAM, or whatever it is you can put in the system that even when you use exactly the same chip. So that's why when you come to the Whitebox concept, not all hardware is equal. So bringing or building Whitebox concepts, you need to take that into account.
So let me take the first question, and you can take the second question. So in regards to performance, yes, there is a penalty on the CPU utilization. But this is like a study done a while ago. The server utilization in a lot of the large data centers is less than 20%. And that was the main reason why server virtualization started taking off, because there's a lot of stranded capacity all over the place. What you want to do is you want to do bin fitting, right? You want to make sure that your server capacity utilization, you figure out ways to increase that. And that kind of led to, I think, the whole, in my viewpoint at least, the server virtualization kind of enabled SDN in the data centers to gather momentum, so to speak. Because when you're dealing with 100,000 or 1 million VMs, you just cannot, they're like million IP addresses, they're different subnets, different logical routers and switches that need to be configured. So SDN, I think, in our viewpoint, and the network function virtualization played a key role in accelerating that process. So we have seen that even if you use, so there are, vSwitches can be used, can be used for overlay mode or in a regular mode. So in those cases where we do not use the overlay mode, which is like using VLANs or physical bridging, the CPU utilization is very low. What we found out is like with this DPDK SDK that we get from Intel, that pin physical pages in memory, 0 copies and things like that, it has brought that CPU utilization down to a very small fraction. In overlay mode, it tends to go up a little bit more, but not so much. See, when you had a server capacity utilization of under 20%, there's a lot of capacity sitting there that you can use. And if I can suck some of the intelligence into my compute nodes, and it allows me to give software APIs to configure that using SDN controllers and OpenFlow and things like that, that makes it more powerful. And going back to this, I just wanted to add one more point. What we find is like, from a hardware vendor perspective, some hardware vendors are embracing OpenFlow and this ability to provide programmable APIs, but it's not fast enough. And I think it's because it leads to commoditization, as Reza pointed out, right? So there is like some resistance there. So white boxes can help maybe push that thing along a little further.
So I want to make two comments. One, I want to add to something that Vinay said. I was lucky enough to be involved with VMware starting in 1998. And I can't tell you how many times I heard the comment of, oh my God, virtualization is never going to work because you have overhead. Yeah, we did have overhead. But I don't think anyone in this room will challenge that virtualization actually worked for servers. And I think that customers realized at some point that I might take a 6% hit from a performance perspective, but what am I getting in return for it? What's the flexibility? What's the automation? What's the capability that I'm getting in benefit? And I think customers will always look at it that way. So it's never perfect equivalent, but there are benefits. The second part, to answer your question, and I think you brought it up a good point, I want to be clear. I'm not saying all hardware is created equal. What my statement was, if I take a Juniper box and I take the same box made by the ODM without the Juniper logo, you can't tell the difference. So today you can go and buy on our hardware compatibility list boxes, which if you look at them, they look very much like a Juniper box or a Dell box without the logo at a fraction of the cost. And that one, it's exactly the same box. If I open it up, you can't tell the difference. Same amount of memory, same subsystems installed in it, same Broadcom chip. Because the OEMs don't design their boxes anymore. They go to an Acton, they go to a Delta, they go to a Celestica or a Quanta and say, I want this many of this box. And again, unfortunately, I can't give you specific model numbers, but you're a very smart guy. Go on Google and search, some of the reference numbers of Dell and the numbers they have in their model number and line them up against Quanta, Delta, Acton. And you'll be surprised at what you find. It's the exact same box. So in that case, there's no difference. And we've had customers who've initially challenged us and taken very specific RFC tests. And one particular customer ran it on a Juniper box in one of our ODMs. Same results came out because it's the same thing. That was my point. But I agree that, yeah, maybe a Cisco box will be slightly geared differently, but there's a lot of them out there that are the same ones.
I wonder if the driver for the white box model is a control issue. Vinay wants to have control over everything that happens in the switch down to the lowest layer so that he can access anything he wants, so that he can make it do things the way he wants it to operate? Or is it a pricing issue? Gee, I can do things cheaper. Because if I look at the PC model, I can go out and buy all the components to make a PC. I can buy an operating system. I can put them together, but I don't, because in the end, it would cost me more than going out and buying an HP platform or something else.
Yeah, I can answer the first part of it. So it's both. It's both CapEx and OpEx, so to speak, right? But if I were to put it in a prioritized list, it would be OpEx first and CapEx second. It's a difficulty of operating a network at that scale with so many compute elements or like virtual elements stranded all over the place, and the agility to provision to, like Mark was talking earlier about flexing up and flexing down in a production environment. That cannot be done by opening up tickets and asking people to go provision new servers and bring servers down. You cannot do that. It has to be programmatic. So to do that, let's say if I have to spin up 200 new VMs because I saw some additional traffic coming in on some web that internet facing, and those 200 VMs could be coming from any of the racks, and they're all in different layer 3s, but they all need to be in one logical layer 2. So these are all things that we don't have to worry about by creating VLANs and complicated convoluted networks. We can do that using, perhaps, I'm giving an example as an overlay network. If I did that, I'd like to be able to provision like not in days or hours, but like in seconds or minutes. And we do that by enabling, so today we do that overlay, so we don't necessarily have to go touch the TORs and all those things for each and every provisioning because it's done in the virtual switches. But sometimes we feel that having a hardware element is good because it gives you some additional speed and scale, things that we may not get necessarily with vSwitches. But I lose out because I don't have the programmatic APIs. And there's also a key difference in, especially I can speak for ourselves. We have a networking group, which is responsible for network equipment, load balancers, firewalls, switches, routers. And there's a compute group, which deals with the servers. And the way we deploy cloud is more compute-centric. We use Puppet, we use Chef, we use Sol for deploying all the servers and things like that. We would like to do the same thing with our network elements too. So these are things like, this ends up being feature requests for our vendors. And what we run into is that the features are not aligned with our goals. And this is where perhaps, anyone who can do that will be in an advantageous position.
So let me, first I totally agree with Vinay. It's OpEx first and CapEx next. And I'll give you a couple examples from things that we've seen from customers. And if you look today in the market and you take a typical Cisco Nexus 10 gig box and you look at its list price and you actually discount it and you take an average discount in the market of 55 to 60%, and some of you guys might get much more, but for the sake of argument, I'll use that. You take that box, you discount it to 55 to 60% off of the list price. You add on top of it their layer 3 license. You add their SmartNet mandatory component. You're roughly going to be in the $25,000 to $30,000 range to get that box for an enterprise customer today. An equivalent 10 gig box from one of our ODM partners, list price, without any discount, is $6,000. You add our license on top of it, and you add maintenance for 3 years, it's under $10,000. List price. So you have under $10,000 list price for a 10 gig box versus 25 to 30K using a 55 to 60% discount. Now, you guys, some of you are from much larger organizations. You probably can get 80% out of Cisco. Discount that further. You'll see that the Whitebox solution is still very, very competitive at list price compared to a discounted Cisco piece. But that's not enough because at a very large-scale customer, Cisco is pretty much willing to do anything to make sure they don't lose the deal. And our largest customer, when we launched our company in June, they had been our customer for a while. And in June, they had 4,000 ODM boxes running Cumulus Linux and 6,000 running incumbent devices. So typically 60 to 40 split. At that time, 90% of their network engineers managed the 60% of the gear, and 10% managed the 40% of our gear. In November, they have 10,000 devices running Cumulus Linux. They still have the same number of incumbent devices, but every capacity they've added an ODM box with Cumulus Linux. They still have the exact same number of people managing our devices, not a single more. And the huge benefit there is the OpEx piece. Because we are Linux, all the tools, Vinay talked about Chef and Puppet, these guys are so large that they have their own technology, open source technology there. Those same tools that apply to their hundreds of thousands of servers apply to their 10,000 switches. And if you have something that can scale to hundreds of thousands of servers, managing 10K switches should not be that much harder. Why is it that if you look at the admin per device ratio, you have such different numbers in your network environment than you have in your compute environment? And actually, that's the part I think is the biggest benefit that Whitebox with Linux brings to the very large customers. You don't need that many people. You still need networking skills, don't take me wrong. Some people say, ooh, you're going to make me fire all my network engineers. That's not true, because you still need to understand how the network functions and how to architect it. But instead of spending time learning a proprietary command line interface, instead of spending time reading the manual of a given company, your guys can actually leverage a set of skills across everything. They still need to understand how networking works, but they don't need to learn anything proprietary to us. And if tomorrow you're unhappy with me, replace me. That's fine. My job is to make sure I provide you the best operating system. I don't want to do that by locking you into a proprietary language or command line interface.
I'd just add one piece to that, because I agree with what both Vinay and Reza have said.
It's too easy. You agree with everything.
We should have had someone up here from Cisco, right? So I'm sure there's someone from Cisco in the room. Good friends of mine, very good customers. Exactly. So it's not just
a very good customer. Which one comes first?
Yeah. Not going there. So it's both OpEx today, it's CapEx today, but I would say for a lot of the customers that we're talking with, particularly in the carrier space, it's the future trajectory. It's not a static point in time. They're looking at what's happened with Moore's law as applied to servers, what's happened with it as applied to networking hardware, and they don't see that going with an incumbent solution where the operating system and the hardware are tied together allows them to ride Moore's law down as the network evolves. So we've had very explicit conversations with some carriers where they say, we want to use your software as a single control plane because we're going to choose this white box for this project, but in 12, 18 months' time, it may be another vendor. Maybe it is Quanta today, maybe it's Acton in 18 months' time, maybe it's someone else, right? But whoever's driving down the cost, they want to be able to ride that on the hardware side and not have to worry about bringing a completely new network operating system in at the same time. So I think that's, that kind of breaking that vendor lock-in is very much a part of what they're trying to do. And, is that CapEx? Is it actually about the software flexibility? It's actually both is tied up together in that.
My name is Recep Ozdag. So what I'm hearing is that the software doesn't have to have Cisco-like features. So you need another number of protocols, but not too many. We're using Whitebox hardware. But there's also a number of vendors providing open source network systems, such as Mellanox, such as Intel with Winover, and there might be others. So in this case, what do you think your business model will be? And I think this is a question really to Cumulus because there are a number of ODMs that provide the hardware. Given that the software doesn't have to be as complicated, and with more support for as OpenFlow comes in, it will be even a thinner client. And combined with these open source alternatives, how do you think your business model will change? Will it be more services because you still need to provide support, or do you think that the open source threat will not be a threat actually? Thank you.
So actually, we don't see open source as a threat at all. I mean, we leverage Linux pretty dramatically, and everything we've done, we've recontributed upwards. So I want to be very clear. Cumulus Linux is a Debian distribution, and we have done patches and done some changes both to the kernel, to Quagga in particular, but all of those have been resubmitted upstream. So we're not holding anything back. The one piece of proprietary technology we have is the Broadcom driver, and that's primarily because of Broadcom intellectual property and access to their SDK. So that's the piece that's not open source. But all the other packages, you'll find them. But you can think of us as a Red Hat, as we provide an experience, an operating system, and the subscription we sell to our customers provides for that, and the support and the maintenance that goes with it. So our job is to provide you a good enough experience or a great experience such that you'll be willing to pay us. Our largest customer is big, has a lot of engineers, but they found that the value we brought them was worth paying us for that piece of software.
Parts of that ecosystem will be open source, and we're going to support those, and we're going to contribute to those. But there's absolutely part of the proprietary technology and know-how we bring is reliable, highly scalable routing stacks, and we're enabling that, but as part of the Whitebox revolution.
Thanks for an excellent panel today. I guess my question is around rapid innovation and who will have the control of the innovation. Is it the chipset companies, system companies, software, middleware, or carriers? What can you guys do collectively as a supply chain to enable a balance of innovation with respect to across the supply chains, from chipsets all the way to the application level?
I guess from my point of view, if you have an open ecosystem and a diverse supply chain, you're keeping everyone honest. The hardware vendors will have to innovate amongst each other to get your business. I'll have to innovate or compete against other software vendors to get your business. I think actually that's the best way to foster the innovation. It's not by me forcing you to for you to take whatever I give you on my timeline. If you have multiple players at each layer, you'll have more innovation.
But today, I think my question is, look at the process that's happening. The chipset companies are talking to the system companies, and system companies are talking to the OS vendors. So seems to be, every time we want to introduce as a carrier a new service, we are sort of at the mercy of, the supply chain. It takes a year or so to come up with a really new advanced, introduction of a service. So is this, I understand, what you guys are doing is all great, etc. But my question is that process going to change, where chipset companies can directly sell to carriers, their innovation, and middleware software companies and so on?
Right. I mean, I have a slightly different take on that. I feel that a lot of innovation is coming from open source these days. I mean, I don't know if you guys had a chance to deploy something called OpenStack for our cloud deployments. And we have one of the largest deployments of OpenStack in the world. And that is all open source. If you look at Linux Foundation, right, that's all open source. If you look at all the virtualization that you have KVM and Red Hat and all this stuff which enable you to virtualize your servers, and Open vSwitch, which allows you to do switching with very rich set of features, all the innovation is in open source now. Now the question is, will the hardware vendors be able to keep up with that and provide the necessary APIs for me to have a very agile data center so that we don't have to open multitude of tickets to cross this organizational boundaries to make things happen. It takes days and weeks to have any change flow through the data center. So it should be done you should be able to rejigger your data center in using just software API. I think that is the trend to me, that is the most exciting part of the innovation that's happening now in the industry.
Yeah, let me turn that around to the audience a little bit as well and say it's also got to be the network operators innovating as well. And when I talk to the hyperscale data center guys and how fast they've been innovating and how they've been looking at these trends and exploiting them, and then go talk with some the large telcos. The large telcos are still trying to are basically trying to redesign an architecture for their legacy networks. The data center guys have thrown that out and are innovating and finding use cases today and deploying much, much faster. And at the risk of being a bit controversial in this audience, I think the carriers actually can innovate a lot faster by breaking down some of the silos that they have internally, and just by taking some applications and deploying them in the networks and building on them. I think that's partly what I guess we're all here for today is to say how can we take some of these lessons from the use cases that have proven SDN and apply them into carrier networks.
I might just add one thing. The one thing that I learned when I was in Barcelona was a very interesting meeting I had with Vinay, with the people from, we'll just call it a major U.S. Mobile carrier. And what I learned is they are so dependent on Cisco that that's what really is the big bottleneck, because anyone who's dependent on Cisco, then the suppliers to Cisco it's a whole proprietary network all the way through. So to break through that, you really need the carriers have to have the courage to break away from Cisco, to try and embrace open source, and if they do so, then all the innovation will flow all the way through. And that's just my opinion.
And that kind of reminds me when eBay was very dependent on Sun Microsystems. And then Sun melted a couple times, and suddenly eBay went to Linux. And I don't think there's a single web scale property in the world today not using Linux and still using Sun Microsystems. I would actually argue that you could not have Google or Facebook without Linux.
You build your network in a way that you're not worried about a single entity going down. Yeah, sure. There was a great question earlier about the evolution of class 5 switches to soft switches, and I'd say that evolution that we're seeing today to true cloud IMS is the ultimate endpoint there. Once you've built that, then actually any one of those server nodes that you've built, and even the whole data center that it's connected to, can go down, and your server should stay up. You should be thinking about a node failure as a capacity reduction, not as a service outage. And if you designed in that mindset, that's the lesson we should take from the hyperscale guys, and that's how you get reliability.
So I think with that, I think we're going to break for lunch. I want to thank you for your participation, and I look forward to meeting all of you after the conference, as do the panel members. Thank you, and a big round of applause for our members.